The first design we discussed for the client-server design problem is really about every time you want to do display, you have to explicitly updates by communicating to the server by following the metadata link. However, is every update really necessary? That's the question, right? Remember when we spoke about the runtime test over here, let's say if you this display definitely is actually going to call the updates for sure. So this update will be necessary because you can see we just did the update on the metadata. On the other hand, when you try to say periodically the next time when you try to call the display for the same app, and then it is also going to call update again. So now, is this update really necessary? Well, I will argue that it's not really necessary because you can see from here to here, there's no updates on the metadata. It simply stays the same. In that case, doing this update over here would be wasting the computing resources, especially if the server simply locates geographically different from where the client is. In that case, you have to really waste the bandwidth for communicating over the network. So that will be some major drawback for this design. Let's go back to the slides and speak about it. Each application, including current condition, forecast, and statistics, they cannot know when the metadata will change. So this is why one of the characteristic properties for the first design is, if you look at the display for each of the apps, the first step is always the updates. Doesn't matter if the update is really necessary. So we should consider the update will be necessary if there has been a change on the metadata, the server side. But it's not the case for the first design. For the clients, you always try to be the safest. You always just do the updates for the display as a first step, even if it's not necessary, as we said before. So this display will be necessary because it's right after the change. And however, on the other hand, this display would not be necessary because there was no actually change between the two display. And then again, this display here will be necessary again because there was a change between the two display. Okay, so that's kind of the idea that we want to think about in order to criticize the first design. So all the applications have to periodically initiate updates in order to keep the display result up to date. To be more precise, always the first step for the display will be to do an explicit updates, whether necessary or not. So each inquiry of the current metadata value is a remote procedure call. In a very common case where the server and client, they simply just exist on the geographically different locations. In that case, in order for them to really communicate, you have to do the so-called remote procedure call. So it's outside the scope for this lecture and this course to see how exactly you can do remote procedure call. For any specific object-oriented programming language that you're actually using, you can definitely look up the proper syntax for that. For now, we'll simply just say that we try to be very general over here. So whenever, for example, when you say here, let me just give you one example. Let's consider this particular communication to the server. When you say metadata.temperature, right? At runtime, it simply corresponds to the current condition app. So it's going to say, now if I want to go to metadata, I need to follow this particular link. So now, in order to really follow this link, it could be that the address over here is not really a physical address for the memory. It might be some URL, or it might be some virtual address that actually refers to some geographically remote server. In which case, to really go for this link, it might take some, it might cause some delay in order for you to get connected to the server. How exactly you actually follow this link will be outside the scope for this particular lecture or this course. You can definitely look up the syntax. But for now, we'll simply say there will be some communication in order to in order to implement this particular feature call or routine call. Exactly how you do it, you can look it up yourself. All right. Alright, so now let's go back here. So it's going to be a waste of computing resources, for example, network bandwidth, if the server is simply just remote. In that case, you actually when there are actually no changes on the metadata, in that case, you just don't need to do any communication. You can simply just use the cached copies of the measures on the current on the local client's storage. How do we avoid such overhead? So now we want to think about how can we improve the first design. Now that we know about its drawback, so now we definitely know the scope for improvement. So we want to say each application should be somehow subscribed, attached, or registered to the weather data. So now we want to say rather than every time, the clients will simply just be the so aggressive. Every time when they want to display, they will simply just update. Every time they just updates, or every time they will just update. Rather than being so proactive, we want to be passive for the application. So that's a key. So we want to say that each application is subscribed, attached, or registered to the server, the weather data. And now let the weather data, let the server be the active part. So whenever there's any change, the server will somehow notify or publish the new changes so that the clients can get the latest change. So the clients will not be responsible for getting the most up-to-date value periodically. They will only get the updates on demand, and the demand will actually come from the server side. Okay, so the updates on the application side occurs only when necessary. So that's really the key when we move on from the first design to the observer pattern.